Hey guys, so today we are going to talk through some more complex examples dealing with exponent rules. You've already learned these rules in your previous exploration that you just did, the assignment before this one. And I thought it would be nice to organize all of these exponent rules for you on a cute little table, and then with a little example with it. So you have all of your rules. I think there are 7 of them. 1, 2, 3, 4, 5, and then I think there are 2 below that. And then we're gonna do what it looks like or what it equals without any real numbers in there, and then we'll do it with some actual numbers and variables. So 0 rule, something like x to the 0, that's just equal to 1. So if you have 24 to the 0, that's equal to 1. 0 power rule, real simple, really straightforward, not a whole lot happens. When you have a product rule, when you have 2 things that are multiplying that have the same base. So notice here that you have an x, you have an x. If this had been x to the a times y to the b, this would not work. But because you have the same base, this becomes x to the a plus b. So in our example where we have x squared times x to the 3rd, this becomes x to the 2 plus 3, or just x to the 5th. And you're done. When you have the quotient rule, when you're dividing, remember that division is the opposite of multiplication. So instead of adding, we're going to subtract a and b. So if you have x to the 3rd over x to the 2nd, this is going to become x to the 3 minus 2, or x to the 1st, which is really just x. If you have anything to the 1st power, you don't need to include that exponent. And if you ever see anything that doesn't have an exponent, it has an invisible exponent of 1. So we'll add that in if we need to in any of our examples here. When you have something being raised to a power and then raising it to a power again, this becomes x to the a times b, or you may just see this written as x to the ab. So if you have x squared to the 4th, this is going to become x to the 2 times 4. 2 times 4 is 8. Clean it up as much as you can. You don't just leave it as 2 times 4. That's weird. If you have a negative exponent like x to the negative a, this is going to become 1 over x to the a. So if we have something like x to the negative 2, this is going to become 1 over x squared. Or if you have something like 1 over x to the negative 2, sometimes this is called the reciprocal rule because what this is going to become is just x to the 2. So like this is just going to flip your fraction because there's an invisible little 1 that lives underneath there. Power of a product, if you have something where you have x times y to the a, this is an example where you have a little invisible 1 here and here. And so the same thing happens as with a power to a power. So this is going to become x to the a, y to the a, because you're just multiplying 1 times a. So in our example where we have x to squared, y to the 3rd, and all of that being raised to the 4th, this is the same thing as saying x to the 2 times 4, y to the 3 times 4. 2 times 4 is 8. 3 times 4 is 12. And you're done. And then power of a quotient is very similar to power of a product, where if you have x over y to the a, remember there are still invisible 1s there, this becomes x to the a over y to the a. Notice that I'm not subtracting or adding my exponents here because x and y are different bases. So in this example where we have x squared over y to the 3rd and that whole thing being raised to the 4th, this is going to become x to the 2 times 4 over y to the 3 times 4. 2 times 4 is still 8. 3 times 4 is still 12, and you're done. But as you get into this assignment, you are going to see that none of them are quite this straightforward. So let's try out some examples that are a bit more complicated. It asks us to simplify the following expressions and that our final answer should only have positive exponents. This is going to be true on your assignment as well, so make sure that even if when you think you're done simplifying, you have negative exponents, that you're doing some work in order to make them positive. So it asks us to simplify this expression where we have 2x to the fourth y times 5x to the third y squared. So I'm going to highlight things that are the same base. Anything that's just a constant, those are the same. Then we have an x to the fourth here. I have an x to the third here. And then I have a y and a y to the negative 2. So when I'm thinking about multiplying these things, the 2 and the 5 multiply just like they would if this whole expression was 2 times 5. And then we have our x stuff. So this is going to become x. This is a product because they're multiplying. So we're going to add the exponents, x to the 4 plus 3. And then same things with the y. Y, there's an invisible 1 here, plus negative 2. Now we just need to clean this up. 2 times 5 is 10. X, 4 plus 3 is 7. Y to the 1 plus negative 2 is a negative 1. You are almost all of the way there, but you need to only have positive exponents. So there is no exponent on the 10. There is the exponent on the x to the 7 is positive. That means those two things are going to stay together. And then what's going to happen to this y is that it's going to go underneath. And the mathematics behind that, if you are interested in figuring out why it just pops underneath and you don't, it's not kind of sitting out front with a fraction, great, pay attention. If not, fast forward about 10, 20 seconds. So when we have 10, x to the 7th, y to the negative 1. I can rewrite this as 10 x to the 7th times 1 over y. That's what that negative exponent rule tells me to do. But remember that there's an invisible denominator here of 1. And so what we can do is just actually do this multiplication. 10x to the 7th times 1 is 10x to the 7th. And then over 1 times y is just y to the 1, or just y. And you're done. So that's kind of the math between, about how this works. And you're done. Oh, right. I don't know why that box looks so weird. Maybe this will look better. All right. Number 2. We have 9x to the 3rd, y to the negative 10th over 27, x to the 12th, y to the 8th. So we're going to do the same thing here. We're going to just highlight the stuff that are the same base. So constants go together, 9, 27, x to the 3rd, x to the 12th, y to the negative 10, y to the 8. Now here we're dividing. So the 9 over 27, just like in number 1, they multiply like normal. Those are still just going to divide like normal. Then we're going to have x to the 3 minus 12. It's always going to be numerator minus denominator. And then y to the negative 10 minus 8. 9 over 27 is 1/3. And then x, 3 minus 12 is negative 9. Negative 10 minus 8 is negative 18. Notice here that both of my exponents are negative, which means they are both going to end up in that denominator in my final answers. So this is going to be 1 over 3 x to the 9th, y to the 18th, and you're done. So if you already have a fraction, the x and the y just join the denominator and their exponents change to positive. All right, we have one last example here. We have 2x y to the negative 4th z over x to the negative 4 x squared z to the 5th, and then all of that to the 4th. You have a lot of options here in terms of what you do first. I tend to clean up everything inside the parentheses and then raise everything to a power and then do a final cleanup. You may choose to raise everything to the fourth power first and then clean up. It is completely up to you. So I'm going to start by highlighting the stuff that is the same. So here I don't have one constant, just the 2. Then I have x to the third, x to the negative fourth, x squared. Then we have a y to the negative fourth. That's only y stuff. And then we have a z and a z to the fifth. Okay. So the 2 is going to stay where it is. You're going to have x to the 3 minus negative 4 minus 2, y to the negative 4. Oops. And then z, there's an invisible exponent there of 1 minus 5. Then that whole thing is being raised to the fourth power. Nothing happens to the 2. X to the 3 minus negative 4. Remember that when I have a negative and a negative, that becomes plus. So 3 plus 4 is 7, minus 2 is 5. Then we have y to the negative 4. Nothing is happening there. And then we have z. Oops. 1 minus 5 is negative 4. And then this whole thing is still being raised to the fourth. At this point, I'm going to raise everything to that fourth power. Do not forget that the 2 also gets raised to the fourth power. So this is going to become 2 to the fourth power. X. There's a fifth power already there, times a 4. Y to the negative 4 times 4. And then z. Oops. To the negative 4 times 4. 2 to the fourth power is 16. That's just multiplying 2 4 times. So 2 times 2 is 4, times 2 is 8, times 2 is 16. That's 2 to the fourth power. If not, you can always use decimals. X to the 5 times 4 is 20. Y to the negative 4 times 4 is a negative 16. Z to the negative 4 times 4 is also a negative 16. Now you just need to clean everything up and put stuff in numerators and denominators. 16 doesn't have an exponent. That means it has a positive exponent on it, so it's going to stay on top. X to the 20th, that's also a positive exponent, so that's going to go in the numerator. And it's going to be over y to the 16th, z to the 16th, and you're done. Head on over, try out your individual practice. Let me know what questions you have and have a great rest of your day. Bye, guys.